Assalamualaikum my dear students. Today on the platform of MS Lectures, I will be explaining to you the very important topic of the biochemistry, that is the competitive inhibition. So I will be explaining to you about the competitive inhibition by the help of the Lineweaver Burk plot. So what is this Lineweaver Burk plot? So I would through the Lineweaver Burk plot I would be explaining to you about the Vmax and the Km. So before telling you about that how the Vmax and Km changes in the competitive inhibition, I would like to tell you about the terms, that what actually the Vmax and what actually the Km means. So talking about the Vmax, what is the Vmax? So Vmax, it is the state which is achieved when all the active sites are occupied. When all the active sites are occupied by the substrates, when all the active sites are occupied by the substrates. So this is a state when we say that Vmax has been achieved. Secondly, what is Km? Km is defined as the Maclaurin's constant, and this defines us the number of substrates. This defines us the number of substrates that are required to achieve half of the maximum velocity. So it determines that how much of substrates are required in order to achieve the 1/2 Vmax, means the half of the maximum velocity. So what happens during the competitive inhibitions? Let's say this is our enzyme. This is our enzyme and this is our substrate. So let's suppose what happens in the competitive inhibition. In the place of substrates, inhibitor gets attached rather than the substrates. So what happened that if inhibitor is attached with the enzyme, product would not be formed. So in order to make the product, or in order to make the product of by the, you can say, attaching of the enzyme and the substrates, what we should need to do? We must need to detach this inhibitor. And how can we achieve this? The detachment of the inhibitor would be possible by increasing the concentration of the substrates. So we would increase the concentration of substrates. Here at the active site of the enzymes, and in this way the inhibitor would be detached and substrate would be here allocated, and the you can say formation of product would be possible here. So what happens? So what this process actually, you can say, what this process has the influence on this Lineweaver Burk plot. So you can see that. So you know that the inhibitor was attached here at the active site of the enzyme. This is clear. So more substrates were required to achieve that threshold in order to make the product. So normal, if we talk about the normal, if 20 substrates were required to achieve the maximum velocity and 10 substrates were required to achieve the Km value, or half of the maximum velocity, it was normal. But in the case of inhibitor, now what happened now in the case of inhibitor? Now 40 substrates are required. Now 40 substrates are required in order to achieve the maximum velocity, and 20 substrates are required to achieve the Km value, that is the half of the Vmax. So you can see that the value of the Km has changed in this competitive inhibition. The value of, this is the notable point, value of Km has changed in this particular competitive inhibition, because now more substrates are required in order to achieve that threshold, or you can say in order to make the formation of the product possible. So you can see that 1 by k, this Km, this line has moved toward the more positive. You can say that value of Km has changed or increased. Now talking about what does the influence of this process has on the Vmax, or maximum velocity. So I tell you that the Vmax would remain unchanged in this regard. In this process, Vmax would remain unchanged. Why? Vmax would not change because the Vmax would be achieved at any point whenever the substrate would be attaching to that enzyme. So that's why only the value of Km would be changed. Vmax would remain constant because when the concentration of the substrate would reach to that point, which would lead to the detaching of the inhibitors, can actually lead to the point where Vmax would be achieved. So that's why Vmax would remain constant in this regard. So I have explained you regarding the Km value and the Vmax in this competitive inhibition, and hope you have understood it well. Last but not the least, don't forget to subscribe my channel lectures. Thank you.